Get ready to rev up your understanding of space and time. So here's the thing: according to Einstein's iconic law of relativity, nothing can zoom past the speed limit he set for our universe. That's the speed of light. But what if you're not a car or a plane? What if you're an ultra-speedy particle called a photon? Well, photons are actually massless particles of light, and they somehow manage to cruise at the speed of light without breaking any rules. But how do they get away with this speeding privilege? Let's dive in and find out. Here's a rewritten version with an energetic tone and hey there. Let's talk about photons, these incredible teeny particles that make up light itself, literally translating from Greek as light. Albert Einstein pioneered our understanding of photons back in 1905 when he was cracking the mystery behind the photoelectric effect. Now you know photons are massless wonders. They can't be split into smaller parts, but can pop into existence and disappear. It's like magic. Because photons aren't burdened with mass, they get to cruise at light speed without breaking any rules. Their properties allow them to hit the cosmic speed limit without ever feeling heavier. Here's how it looks rewritten with that context, and that's what slows down everything else from reaching light speed. Mass keeps increasing infinitely as velocity goes up, and we'd need an endless supply of energy to keep going. But photons are a different story. They don't carry mass, so they can travel at the cosmic speed limit without any issues. In fact, in the perfect vacuum, the speed of light is an impressive 299,792, 458 meters per second. That's just how fast these massless particles get to cruise. Let's dive into this incredible universe. Speed limit: photons zooming through space at 299,792, 458 meters per second. That's just how fast they cruise in a perfect vacuum. You'd reach Mars in about 3 minutes if you could move at this speed and escape the gravitational pull of black holes. But here's the catch: nothing can break free from a black hole, because guess what? Nothing can match light speed. Now, while we don't know for sure that objects can't hit the cosmic speed limit, it doesn't stop us from wondering about the endless possibilities if we could move at light speed. Wouldn't that be an amazing superpower? Imagine, for instance, if something in space reached the cosmic speed limit of light and was hurtling straight towards our home planet. Considering the daily bombardment of meteorites, space debris ranging from tiny particles to sizable rocks that enter Earth's atmosphere, but rarely cause significant harm, we might initially think nothing out of the ordinary has happened. However, a body traveling at light speed would pose an entirely different threat. If such an object were on its way towards us and couldn't be deflected or destroyed, it would result in catastrophic consequences. You see, when shooting stars zoom towards Earth, things get intense. Initially, they're cruising in space, no resistance, just free fall. But that's about to change as they hit our atmosphere, filled with air particles that pose a major obstacle. The friction caused by this interaction is like slamming on the brakes at top speed. It rapidly drains their energy and forces them off course, burning up almost entirely before reaching the ground. This atmospheric barrier acts as Earth's shield against most space debris, saving us from potential harm, but also making some shooting stars an explosive spectacle in the night sky. Let's dive into a hypothetical scenario that's more physics fantasy than reality. Imagine a needle-sized object zipping through space at the speed of light, which is about 282 miles per second, an unfathomable pace. If this tiny traveler was somehow propelled to light speed and hurtled towards Earth, it would indeed face resistance as it entered our atmosphere. But here's where things get mind-bending. According to Einstein's theory of relativity, nothing with mass can reach the speed of light. It'd take an infinite amount of energy. Picture this: a minuscule meteorite, no bigger than a sewing needle, hurtling through space at an incredible velocity. Let's say it's approaching the speed of light. At first glance, this tiny intruder wouldn't raise any eyebrows. Most objects in its size range burn up in our atmosphere or go unnoticed. But what if we were to amplify its speed to nearly the cosmic limit? The energy this needle would release upon impact would be staggering, equivalent to the kinetic force of the moon as it orbits Earth, an unfathomable amount of power that could cause unimaginable damage on our planet's surface. Imagine this catastrophic scenario: a minuscule meteorite, accelerated to almost light speed, hits our planet with an unfathomable force. The impact creates an enormous hole that melts its way through the Earth's surface, leaving behind a trail of destruction. As it plunges deep into the crust, intense radiation and growing plasma emerge through the gaping wound, releasing an enormous amount of energy. Within seconds, the impact site transforms into a blazing, glowing dust cloud that rapidly expands outward from the needle's point of entry. This explosion would outshine the sun as the Earth releases heat from the incinerating collision. It would be nothing short of apocalyptic. Let's picture a scenario where a minuscule meteorite, hurtling at nearly the speed of light, hits our planet with an unfathomable force. A force so powerful that it would upend life on Earth in a split second. The moment the needle pierces the Earth's surface, everything changes. The planet would be set ablaze as it transitions into a searing cloud of plasma that expands relentlessly. In the blink of an eye, our home would be catapulted out of its orbit. But by then, all life forms would have succumbed to this cataclysmic event. The shockwave generated from the Earth's transformation wouldn't just affect the planet itself. It would also reverberate across other celestial bodies, casting a massive plasma wave that would leave an indelible mark on their surfaces. Moreover, the sun would find its radiance obstructed by an impenetrable veil of dust waves, effectively shrouding our solar system in darkness. This apocalyptic chain of events is a chilling reminder of just how vulnerable we are in the vast cosmos, and we can only hope that Einstein's law of relativity holds true to avoid ever finding ourselves face to face with such an unimaginable disaster. You can keep gazing up at shooting stars tonight with a sense of wonder. We're glad you found this information enlightening. If there are any remaining questions or topics you'd like us to cover, please feel free to express them in the comments below. In case you're curious about mesmerizing magic tricks, check out our other video that counts down the top 10 most astounding illusions. Don't forget to hit that subscribe button for more thrilling content, and we'll catch up with you in our next video.